Hey everybody, welcome back to a new video on this channel, and today we have a look into caching in Nitro. Let's go. Nitro is especially well known as the server engine of Nuxt.js, but also other frameworks like Analog or Solid Start, 10-Stack Start, which is coming up soon, and so on, so on, so on. But what exactly Nitro is special about? Well, lots of things, right? Like working runtime agnostic, providing lots of features out of the box, integration with certain things. And we already took a look at route rules in another video after explaining general render mode ideas and so on and so on. Today we want to focus on the caching part because, as I mentioned in that video back time, there are some easy ways of caching things in Nitro, and we also want to dive into some more in-depth examples of like changing cache keys and setting it up in general, even invalidating the cache on your own besides the general caching rules. So let's get started with our Nitro application and see what's happening there. In our case, we don't have a Nuxt application running, just the plain Nitro application actually. So there's only Nitro pack in here in our dependencies. And we have a Nitro config just set up the source directory to server. So if you would say you would use Nuxt.js, for example, you can just copy that server directory over and things should work very similarly. And we have here an API route called test, where we just return the latest date. And if we now check the browser, we will see obviously a 404 because we didn't set any index page. We could do that through server routes. And if we go to API test here, then we see the date as we would expect it. Perfect. And we see we refresh it, we get the new date. So now, of course, we want to dive in the topic, which is caching. And we start with the easiest way general. We want to set up route rules with caching. If you don't know what route rules are, no problem, I'll explain it right away. Then we set up the caching things with SWR, without it, some max age, and then we get into some more, let's say, sophisticated examples. And to set them up, we go into our Nitro config. Also in Nuxt, it would be the same way. We say route rules over here, and then we can, for example, say, okay, we use /API/test, so our API endpoint, and we want to set up a cache route rule over here. So we could say the max age, the time it is cached, right, would be like 10 seconds. So far, so good. And we disable SWR for now. We also have a look what this is doing in a bit. Some of you might know it already, but still, it doesn't hurt to explain it once again. And now if we reload our test API endpoint, then we see the following. We see the whole thing changed, and now if we reload it again and again, it stays the same. After, well, a couple seconds, then it will not stay the same anymore because the max age is reached at some point. Here we go, and we get the new value. So after 10 seconds, the cache is gone, and the next request after these 10 seconds, well, that will return the new value. So this works pretty well and straightforward, but okay, returning the newest date is not the most expensive operation. So maybe let's add a little promise that we await for like 3 seconds and see what's happening then. This is done pretty quickly by just writing an await down here with a new promise saying, okay, we want to resolve it. And we set a set timeout here to call resolve eventually with a delay of 3000. And then we are good. So now, of course, we have a big benefit. So if we go back to the browser here and refresh, this will take a little bit at first, but then we get the data. And now, of course, it's cached. It will work pretty well again. But of course, now, after the next 10 seconds pass, after the cache is then invalidated, let's say, so the cache is expired, that's it, the TTL is over, the time is over the past max age, then that promise, well, it has to be awaited again to get the new data, but then the data will be fresh. So if we jump to the browser real quick, then we'll see if we refresh now, it will take a little bit, and then we get the update over here. But of course, now we see, okay, yes, 3 seconds are quite some time, right? And if we want to avoid that, the user will always have to wait for these 3 seconds after the cache is invalidated. We can use a different technique using stale while revalidate. And you might know that from the front end already to say, okay, we give the user old data while the new data is fetched in the background. Let's implement it and see what will happen. To implement that, we just switch the SWR flag over to true. And the whole idea is pretty simple now. If we go to the browser, then we refresh and we see, okay, we get the stale data, even though the cache is already, well, it shouldn't be triggered. But it's called stale while revalidate, so that's the whole idea. And in the meantime, in the background, the new data is fetched again, and the next user will get the fresh data. So the big benefit of this, now we get the cache data, and here we go, it was revalidated in the background because the max age has been passed. If we refresh this a couple more times, we see we get the old data. If we then wait a little bit longer after the 10 seconds are over, we refresh it, we still get the old data because it's then revalidated in the background. And if we then refresh, we get the new and fresh data that is cached. So the benefit here is more or less that users will never have to wait for your promises, for calls. The downside is though that at least one of the users, they will get old data, even the cache time is past that already. And we can even change that if we want to. There is another option that we can update to make sure, okay, if it's like really, really old cache data, then we don't want to serve it at all. And that one is called stale max age. So if you set a stale max age, let's say to 30 seconds, then we can make sure, okay, if the data in the cache is older than 30 seconds, then it will not be served at all anymore, and we have to wait for a promise again. So let's take a little bit, see what will happen if we refresh the browser now after waiting for 30 seconds and making sure the data is really, really old. And if we now refresh the browser, then we will see that actually 3 seconds pass until we get the new data. Yeah, there was a bit of time in between because that stale max age time is actually considered. And then we say, okay, the response is too old. We don't want to send it. We rather let the user wait to get the new info. So far, so good. And the caching route tool is super flexible. It's very helpful. But sometimes you might want to either have more fine-grained control or even more settings, because what we can't do right now is, because we're in the config of Nitro or Nuxt, whoever define it, we can't set functions in there, right? We can't write, okay, what to invalidate, how to define the cache key, and so on, because these configs have to be serializable. So let's see how we can tackle the problem with a new function for our Nitro event handlers. And the solution to our problem lies in this defineEventHandler function, and we can just rename it to say defineCachedEventHandler. So we basically do the same thing we do here in our route rules in the Nitro config, which we can fully scrap for now. We can do the same thing just in our own Nitro event handler. For this, we have a second argument, right? First the handler function over here, and then we have some options. So here we have all the caching things from the route rules and even more. So we can set the max age here to 10. We can set the stale max age to 30, for example. And there are even more options. So for example, now we can also get a key. We can say, okay, based on the event, please return the key, which could be event.path, which could be any query parameters. You basically decide what you want to set it there. And that's pretty convenient, not only because you sometimes have preferences on what to cache how, but also it's easy to identify these keys in your cache, right? But before we define any of these, let's have a quick look how the Nitro caching looks like actually. Because if you go to .nitro in here, in our folder, or in the .nuxt folder, if you're using Nuxt.js, we have this cache folder down here, and then it says cache Nitro routes, and we get this API test and then some hash JSON. And let me quickly nicely beautify that here. So here we have some saved information. The value, which is basically the whole response that we saved there of the whole handler, with the code, the headers for cache control, and the body, which will eventually be sent over, modified time when it expires, and some integrity. That's basically important to know when the cache should be changed or not. So this is what's been saved to the file system in dev. And the best part is, first, it's really nice to debug. Also in dev, you can delete it to basically invalidate the cache yourself. And talking about cache invalidation, we also have a look into that a little bit later. But now we want to see how we can change the name of the file and how we can adapt a few things here and there. Be aware also that if you use headers for caching, they will all be dropped unless you define a varies option to say, okay, these headers should be taken into consideration. So don't forget that. The next thing, well, of course, we want to set a key if we want to. So we can say either it's based on the event, or we can just say, okay, the get key that's static, it's always tests cache, for example. So if we save the whole thing now and go into the browser, we would call our test API again. Then we could take a look eventually in here, and we would see in a second, oh yeah, there we go. Cache, test cache. It's not under routes anymore, but handlers now, because the routes are when you don't define a cache key directly. And here we get more or less the same thing, just a different date. Lovely. And also we disabled SWR, so the scenarios are slightly different. Nevertheless, let's do one more thing, because yeah, right now you see it's saved in the file system over here in dev time. But what if you want to save things in Redis, in the KV store, somewhere in Vercel, Cloudflare, whatnot, MongoDB, doesn't matter, well, then you can do so. You can change where the whole cache is saved or only parts of it. And to do so, you can define your own base. So we can say here, for example, also cache important, something like that. And with that own cache base, it won't do much on its own. What you can do though is let's define this cache in our Nitro config. So in here we have the storage option, right? And then we can say cache important, for example, and define a driver here. Say this should use Redis or Cloudflare, whatsoever, whatever you want, and then define the connections. So you can not only split them up into different places, you don't have to use all at once, you can change that. And as you might already know from the use storage video, where I also talked exactly about the topic, but not only directed to caching, but also saving data in general, you can also set it up in dev and in prod differently. So in dev mode, you can save everything in the memory or in the file system or wherever you want, while in prod, you might want to connect to your KV store, to your Redis and so on. Makes it easier to debug and to work with locally. And to do so, you can use the simple dev storage option over here and then define the same thing, cache important, to say, okay, you know what, in dev, the driver should just be the file system or the FS Lite driver if you want to. And that's all. So even that works without a problem. And from here, there are even more things to do because you can also define some functionality to say when should the cache be bypassed or invalidated. These are things you can't define otherwise because, as I mentioned, these are functions, so you can't put them in your config. And you can then say, okay, if this and this parameter is given, please just don't cache it at all. Or like you can say, hey, if this and this parameter is given, then remove the cache, or just like straight away bypass the cache and make sure that you get the freshest version. Especially useful when you have some kind of preview mode and say, if the preview query is there, then give me the new stuff. So you're very, very flexible here with caching. But the flexibility is not at an end yet. We have one more thing because we can also define it even more fine granularly. Because sometimes you don't want to cache a whole event handler, or maybe you have a reusable function that you want to cache. So let's create a server utils folder. In there, let's do like a post.ts in utils. And just imagine you have some kind of API call and said, okay, you have a function called getPosts uncached, right? So in here, we can just say, okay, we use $fetch, which is also available on Nitro, of course. We don't want to call a test API, though we also could do this. But instead, well, let's just say we call the JSON placeholder API here with posts, and then we want to have some param. So let's say the number of the post as of course, let's say post number might be a bit more declarative to be a number. So let's say posts pass post number. So far, so good. We return the whole result and then we're fine. So this is of course not cached and will take some time. But what if you could just say, let's export a const here that says get posts, and that's an async function eventually. But what if it's just cached? And you can do that. You can just use defineCachedFunction over here to, well, cache certain parts of the application. And this works very similar to defineCachedEventHandler. It's just on a smaller scope. It's in a function that you can reuse through different places in your Nitro backend, right? So you can use it in different handlers and will all share the same cache key. Super useful, especially if you handle third-party APIs or even calling your own ones. And to finish up that function, well, first of all, you can pass anything in here. So what you of course want is the number, right? So let's do post number here as well. And now you can say, okay, let's get post uncached. And this passes just the post number in and we're fine. So the whole thing is cached now. And the best part is, after that, we can even define what we had before. The max age, for example, the base. And as I said, it works the same as defineCachedHandler. defineCachedEventHandler, to be precise. So it works exactly the same, and we can also give that a try in a second. It's just one more thing that's important, because first also you can set the cache key here and so on, and it's very nice to pass in the event here as well, especially if you use edge handlers, because with the whole edge handler event loop, we use a fetch-based approach and not request response like a node. So we need that event to eventually make sure, okay, even after you called your API and things should be cached, we can use event.wait until things have been resolved and don't shut down the worker instance. So it's always a bit better for like more runtime agnostic code to pass in the event, even if you might not necessarily use it, though very often you want to. In our case, we don't necessarily, but we still import the type h3 event here from h3, of course, and we pass that in here. Even if we don't use it, we put underscore in front and it's fine. So what we can do now is, of course, we have that defineCached function and we're good. We have get posts. We see it will return a promise. We didn't type much here, so that's why it's returning unknown. Otherwise, we'd have a proper type signature. And we can even use this either in our defineCachedHandler or, of course, in a non-cached handler, which makes a bit more sense to call the whole thing. So we would just say, okay, you know what? Let's add a new one. Let's say posts.ts. And maybe we want to say, okay, let's get the cached posts and then do something with them. So we say const posts equals await get posts, and we can import them. But we don't even necessarily need to because they're also auto-imported. In this case, we can roll with this with event, and let's get post with number 1. That's fine. And maybe we say, okay, we don't want to cache it because we want to check something in real time that can't be cached. So instead, we have the post, singular actually, because it's one post, and do something with it. And this gives us lots of flexibility, especially if you would use this around the application. That also means that in every now and then you have to handle caches a bit different and think about like, okay, what invalidates where? And talking about invalidation, this is another thing. You can, in dev mode, really easily invalidate a cache if you restart the server, delete the cache folder or the files, as I've told you before. But in prod, you can't easily do it. Luckily, there's a good way around it. So let's have a look into that. To invalidate certain cache parts, we need another route, and ideally this is also protected. Let's call it invalidate.ts. Especially important because here you want to somehow get the cache key that's necessary to invalidate the entry. And the best part is that we know a lot of things. So group-wise, we have all the info we need in here in our dev mode. Because in the cache folder, that's basically the path to the cache. So if we say like, okay, our key would be something like Nitro, then /handlers, /_/test cache.json. This is more or less our key. We could now replace the slash through colons, which is a more accurate cache key actually, because slashes in some systems, it's a bit tricky. So we just use this. It's the easier way, but both should work interchangeably. And now you might wonder, okay, wait, how do I figure out how exactly I get that whole key? Where does Nitro handlers come from? Where does this underscore? And well, test cache JSON, you know already. So let's have a look. If we take a look at our test file, the get key part is of course the last thing before the JSON, right? Get key, test cache. So far, so good. Then there are two other things. There is a group you can set. If it's not set, then depends. If it's a handler you cache, it's called Nitro handlers. If it's function you cache for defineCachedFunctions, Nitro functions. And if it's something else you set, then up to you, right? So we've also seen that already. If you use a route, for example, to cache, it's Nitro routes. So this is also nicely reflected over here, but you can also change it to your desire. And then you can also pass in a name. Usually that's inferred from the function name, but as we do an export default, we don't really have a name here. We could, of course, name that function nicely and then would be used. If there's no name, then the underscore comes in that we see here. So the underscore is basically just saying, okay, we don't have a nice name for that. And then the test cache part is the last thing, right? Our custom cache key. Otherwise, it's generated like we've seen here, API test by the route. That's also fine. Nevertheless, that's how you can basically set up the cache key. And now you wonder, okay, we have the key, but what does it help? How can we remove things? And the answer is unstorage the integration through use storage. And we do it by simply calling use storage here. And then we use the cache, which is the default storage for all our cache. Except if we change it, of course, we say like it's cache important and so on, then it should be cache important instead, right? So we can say, okay, let's change this here back to cache for now, or even remove it because we don't. Let's keep this part here for exemplary reasons and keep that on. And now we say, okay, we can await it and say, okay, we check, does the cache has our key, right? So we say const has item is await use storage cache has item. And if we return the whole thing, then let's see what happens in our browser. And surprise, surprise, it says true. If we refresh it, it stays at true because in there, the cache entry is available. So now there's just one thing to do. We have to delete it, and we can delete it similarly to how we request it. Because we can just simply say, okay, if there is that item, then just say await, use storage, cache. You can also dry that a bit up to use the cache, like save it over here. So like, I don't know, const cache storage is use storage cache. And then we say cache storage dot. And then we say, okay, you know what? Goodbye. We remove it. And then we can just check it once again if we want to say like, okay, if it's still on there. So let's try this. Let's run the code in the browser and see what will happen. And it turns to false, which is expected because we removed the whole thing. And if we check back in our file system locally, in handlers, it's gone. It's fully gone because the cache entry is not there anymore. And now you might wonder, okay, Alex, you've shown it works in the local file system, but does it work in production? And the answer is, beautifully, yes, it does. Because unstorage is also handling your production connection. So things will just work if you define access to your caching services. And as long as you do that, that's all fine. So as long as your app is actually caching to a different service, that way you will always make sure that you can connect to it and remove it. So the LDR cache invalidation needs a little bit of legwork. You have to find out the cache key. You might want to pass it in, have a list of cache keys that are allowed to remove, maybe like need some kind of API secret to ensure that nobody is maliciously calling that and removing all your caches, but it's definitely possible. And you can even hook it up with a little app interface, with a webhook. Sky's the limit because it's all programmable. But I think that's mainly everything around caching right now with Nitro. We have super powerful things from defineCachedEventHandler over to defineCachedFunction, and well, give it a try. Let me know, have you used any of these? I've used these plenty in different projects with SWR, without it. So let me know what you think. Write it all the way down in the comments and you read them all. And please feel free, if any questions, just let me know. Code is usual in the description too. So looking forward to see you in the next video or the latest. Check also out the new Stage Review episodes. Always worth a listen, where Michael and I are discussing lots of amazing things. We also talked with Evan for a little bit, with Daniel Rowe, and many more people, many more amazing guests. So yeah, looking forward to catch you there as well. And I hope to see you in the next video. So have a great time and happy hacking.